Good day, everyone. Today we will be discussing about regression analysis. So last meeting we discussed about Pearson correlation, and that topic will be very essential in order for us to easily understand about regression analysis. I just want to clarify that the regression analysis that we will be discussing today is all about linear regression, because there are two types of regression analysis. The first one is the linear regression, and the second one is multiple regression analysis. If we're dealing with three or more variables, we're dealing with multiple regression analysis. But if we're dealing with only bivariate data or two variables, it implies that we're going to use linear regression analysis. That's the reason why today we will be discussing about linear regression analysis. Let's start with discussing about best fit line. The best fit line is a straight line that best illustrates the trend or direction that the data points seem to follow. It is called the best fit line or line of best fit. This line of best fit can be estimated from two data points on the scatter plot. This is the illustration of line of best fit or best fit line. As you can see, we already discussed how to create a scatter plot on our week 6 topic. And then we already know the direction and strength based on the illustration of the scatter plot. So in this one, we already have the x-axis and the y-axis, and we already know how to plot points and how to create a scatter plot. As you can see, there is what we call, so this one, you know that the trend of this line or this scatter plot is negative, while the direction, however, this one, this is also a scatter plot. As you can see, the direction of this scatter plot is positive. Now, as you can see, I draw a line. That line is what they call the best fit line. And our goal for today is to know the equation of that line so that we can now predict the given dependent variable using the data of the given independent variable. Let us now have an example. So the table shows the hours spent in studying and the score in the recent quiz in basic calculus. So if the students will be spending 1 hour in studying the quiz for basic calculus, the score is 4. So if the student will spend 2 hours in studying for the basic calculus quiz, the score is 3. So as you can see, this is our data. And so we have hours spent in studying and scores in basic calculus. Now, the first thing that we're going to do is we're going to apply what we have learned on our last topic, which is Pearson correlation. So we're going to start with writing the x values and the y values. For x values, okay, so we already write all the x and the y values. Now, what are you going to do is to like what we learned last meeting, we're going to identify or complete the given table for the third and fifth column. For the third column, we have x squared column. For the fourth, we have y squared column. And for the fifth, we have xy column. So now, what are you going to do for x squared column? We already know that you will be able to find the squared of the given value of x. So, for instance, we have 1. So you already know that 1 squared is equal to 1. And then we have 2. So we already know that 2 squared is equal to 4. For 3, 3 squared is equal to 9. For 4, we have 4 squared is equal to 16. Just always remember that squared means that you are multiplying the value by itself. So for 5, we have 5 squared or 5 times 5, which is equal to 25. For 6, we have 6 squared or 6 times 6, which is equal to 36. And for 7 squared, we have 7 times 7, which is equal to 49. So for y squared column, what are you going to do? You're going to get the squared of the y column. So we have 4. 4 squared is equal to 16. For 3, we have 3 squared, which is equal to 9. For 8, we have 8 squared, which is equal to 64. For 6, we have 6 squared or 6 times 6, which is equal to 36. For 12, we have 12 squared or 12 times 12, which is equal to 144. For 10, we have 10 squared or 10 times 10, which is equal to 100. And for 8, we have 8 squared or 8 times 8, which is equal to 64. So we are done with the fourth column. For the fifth column, what are we going to do? That is the xy column, which implies that you are multiplying the x and the y column. So meaning, we're going to multiply x times y. So we have 1 times 4, which is equal to 4. So we have 2 times 3, which is equal to 6. We have 3 times 8, which is equal to 24. We have 4 times 6, which is equal to 24. We have 5 times 12, which is equal to 60. We have 6 times 10, which is equal to 60. And the last is 7 times 8, which is equal to 56. Since we're done completing the given table, the next step is what are we going to do is to add all the given values on each column so that we can get the summation of x, summation of y, summation of x squared, summation of y squared, and summation of xy. For summation of x, we have 28 because if we're going to add 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, the answer is 28. For the y column, we're going to add all the values, and then adding all the values, we have summation of y. So if we're going to add 4 plus 3 up to 8, we have 51. For the x squared column, we have 1 plus 4 plus 9 plus 16 plus 25 plus 36 plus 49, we have 140. For the y squared column, adding all the numbers on y squared column, we have 433. And adding all the numbers in xy column, we have 234. So since we already have those things, it is now time for us to recall our lesson about Pearson correlation. So we already know that the formula in Pearson correlation is R is equal to N, summation of xy minus the summation of x times summation of y, all over the square root of the quantity n summation of x squared minus the quantity of summation of x squared times the n summation of y squared minus the quantity of summation of y squared. So the first step that we're going to do is we're going to substitute all the given values to the given formula. So instead of writing n, we're going to write 7 because as you can see, we have 7 values. Next, we're going to substitute summation of xy. As you can see, the value of our summation of xy is 234. So instead of writing summation of xy, we're going to write 234. So we're going to bring down minus. Now, what are we going to do instead of writing summation of x? We have the value of summation of x, which is 28. So we're going to write 28. And then instead of writing summation of y, we're going to write 51 because our value of summation of y is equal to 51. Now, we're going to copy the square root, and then instead of writing n again, we're going to write 7. Instead of writing summation of x squared, we're going to write 140 because our value of summation of x squared is equal to 140. Bring down minus. Now, instead of writing summation of x, we're going to write 28. So don't forget to write a parenthesis, or so we have parentheses 28 and then squared. Now, instead of writing n, we're going to write 7. Instead of writing summation of y squared, we're going to write 433. And then we're going to copy minus. And then instead of writing summation of y, we're going to write 51. So instead of writing summation of y, we're going to write 51 and then write squared. Now, the next step that we're going to do, we're going to simplify 7 times 234 minus 28 times 51. Pressing that on your calculator, you're going to arrive with 210. Next is, we're going to simplify this one. 7 times 140 minus 28 squared. 7 times 140 minus 28 squared is equal to 196. And then, we're going to multiply the answer of 7 times 140 minus 28 squared to the answer of 7 times 433 minus 51 squared. And the answer is 430. So now we're going to arrive with this one. Now, the next step that we're going to do, we're going to simplify square root of 196 times 430. Pressing that on your calculator, you can use this one. So square root of parentheses 196 times 430 close parentheses. So that we can arrive with 290.3101789. Now, after that, we can now divide 210 by the denominator. Dividing that, we can arrive with r, which is equal to 0.72. So, you already know how are you going to interpret r, which is equal to 0.72. Looking on our correlation scale, positive 0.72 will fall on the range 0.861 to 0.80. And this has a positive high correlation. It is positive because the value of r is positive, and based on our correlation scale, 0.72 is having a high correlation. That's the reason why if we're going to interpret this r, we have positive high correlation. Now, after this one, we will be using this one in order for us to solve or find the given equation of the line of the best fit line. So let's now have linear regression. This is now the application of our new topic wherein we're going to identify y equals ax plus b. Now, how are we going to find a? So to find a, what are we going to do? We're going to apply this formula. Sorry, it's just only one equals. So a equals n summation of xy minus the quantity summation of x times summation of y all over n summation of x squared minus the quantity of summation of x squared. So we already have the values for this one. So what are we going to do? So it implies that completing the table and making sure that the summation of all the values on the given table are correct will make you an assurance that you can get a correct solution for the value of r and for the linear regression. So it's better if you're going to try, double check your answer with the table so that you can assure that you can get the correct answer for the value of r and the linear regression. So now instead of writing n, we're going to write 7. Instead of writing summation of xy, we already know that summation of xy is 234. Bring down minus. And then instead of writing summation of x, we're going to write 28. And instead of writing summation of y, we're going to write 51. Instead of writing n, we're going to write 7. Multiply to summation of x squared, and summation of x squared is equal to 140 minus summation of x, which is 28, which is 28 squared. Now, simplifying or pressing on your calculator on 7, parenthesis 234 minus parenthesis 28 times 51, close parenthesis, we can get 210. As you can see, this is just only the numerator, the value of the numerator on the value of r. Now, for 7 times 140 minus 28 squared, you can also press this on your calculator. Squared can be pressed on the calculator 28 times 28. So it can be 7 parenthesis 140 minus parenthesis 28 times 28. Now, the answer for that, if you're going to use your scientific calculator, the answer is 196. So dividing 210 by 196, we can have 1.07. So thus it implies that the value of a for y equals ax plus b is equal to 1.07. Now, since we already have the value of a, it's now time for us to find the value of b. So to find the value of b, we're going to have b is equal to summation of y. It should be a. Summation of y minus a summation of x all over n. So instead of writing summation of y, we already have the value of summation of y, which is equal to 51. Bring down minus, and then instead of writing a, we're going to write the value of a, which is this one, which is equal to 1.07 times 28. Our 28 is summation of x. Now, all over n, and our n is equal to 7. Pressing on your calculator, 51 minus 1.07 parenthesis 28 close parenthesis, we have 21.04. 21.04 divided by 7, we have 3.01. So we can say that our value of B is equal to 3.01. Now, substituting the value of A and value of B on y equals ax plus b, we can say that the equation of the best fit line is y is equal to 1.07x plus 3.01. Now, it is now very important because we can now use this equation in order for us to predict the given dependent variable using the given independent variable or the given value of the independent variable. So let's now have the example. So let's now predict the scores of students in quiz in basic calculus given the number of hours spent by the students in studying. If the students will be studying for 10 hours, so using the equation, we have y equals 1.07x plus 3.01. So it implies that x is equal to 10. So substituting x is equal to 10, we can have 1.07 times 10 plus 3.01. So pressing that on your calculator, it implies that y is equal to 13.71. Since we're dealing with the score, we can now approximate the value. So approximately we have 14. So therefore, we can say that if the student will spend 10 hours in studying the quiz for basic calculus, the student can get 14 points. How about if the student will spend only 1.5 hours in studying? So what will be the possible score of the student? So using the formula y equals 1.07x plus 3.01, we're going to substitute x, which is equal to 1.5. So instead of writing x, we're going to write 1.5. So we have 1.07 times 1.5 plus 3.01 will result to 4.62. Approximately, it is equal to 5 since we're dealing with the score. So therefore, if the student will um, spend 1.5 hours in studying for the quiz in basic calculus, he or she can get 5 points. So, as you can see, linear regression or regression analysis is very important if we're going to predict the value of the dependent variable given the value of the independent variable. But just always remember, it is very important that you're going to identify the equation of the best fit line. Let us try another example. Mr. Prim is interested to determine if there exists a significant relationship between LET results and teachers' performance rating for the school year 2019-2020. On his study, he plans to use a regression analysis to predict teachers' performance rating and use this as basis of admitting new senior high teachers. So in this study, Mr. Prim will be using the LET result and teacher's performance rating. He will try to check if there is significant relationship exists between the two. And if there is significant relationship exists between LET results and teacher's performance rating, then he will be using regression analysis in order for him to identify the equation of the best fit line so that they can use that equation in admitting new senior high teachers. Let us now have the solution. So let's start with identifying the value of R using the Pearson correlation. So here is the solution of the value of R. So we're going to complete the table. In completing the table, we're going to start writing the X and the Y value. So we already know that the X value is what they call R independent variable, while our Y value is what they call R dependent variable. So in this example, we already know that let result is what they call our independent variable, while our y value is what we call our dependent variable. So our dependent variable in this problem is the teacher's performance rating. Now, the first thing that we're going to do, we're going to get the square root of x column. So we have 5929 because 77 times 77 is equal to 5,929. Next is we have 6,241 because 79 times 79 is equal to 6,241. So using the same pattern, we can get the value for x squared column. For y squared column, we will be just simply multiplying y 4.20 times 4.20, we have 17.64. Ay, shucks, mali ito. And then 4.5 times 4.5, we have 20.25. So using the same pattern, we can get the value for y squared column. So for xy column, we will be multiplying x by y. So 77 times 4.20, we have 323.4. 79 times 4.5, we have 355.5. And following the same pattern, you can get all the values on xy column. So next is we're going to add all the values on each column. So adding all the value for x column, we have 556. So our value of summation of x is 556. Adding all the values for y column, we have 31.15. So that is our summation of y. And then adding all the values for x squared column, we have 44,230, and that is our summation of x squared. Adding all the values in the column y squared, we have 138.8775, and that represents our summation of y squared. And then adding all the values on xy column, we have 2,477.9, and that represents our summation of xy. Now, what are we going to do? We're going to apply again the formula for Pearson correlation, which is n summation of xy minus summation of x times summation of y all over the square root of the parenthesis n summation of x squared minus the quantity summation of x squared multiplied to n summation of y squared minus the quantity summation of y squared. Now, we're going to substitute all the values that we have. So instead of writing n, we're going to write 7 because we have 7 values or 7. So we have 1, 2, 3, 4, 5, 6, 7. Now, instead of writing summation of xy, we have the value of summation of xy, which is 2,477.9. Bring down minus. So instead of writing summation of x, we have 556. And then instead of writing summation of y, we have 31.15. Now, for our denominator, instead of writing n, we're going to write 7. Instead of writing summation of x squared, we have 44,230. Bring down minus. We have summation of x, and our summation of x is 556 squared. So we're going to bring down the squared, or copy just the squared. And then we have n, which is 7. Summation of y squared, which is 138.8775. Bring down minus, and then summation of y is 31.15, and then copy the square. Now, pressing on your scientific calculator, 7 times 2,477.9 minus the parenthesis 556 times 31.15, we have the value of the numerator, which is 25.9. Now, we're going to start solving 7 times 44,230 minus 556 squared, we have 474. Now, 7 times 138.8775 minus 31.15 squared, we have 1.82. Now, so you're going to simplify the denominator. So in simplifying the denominator, we're going to have square root parentheses 474 times 1.82 close parentheses, and we can get 29.3714. So dividing 25.9 by 29.3714, we can get the value of r, which is equal to 0.88. Now, how are we going to interpret this value of r? So if we're going to recall the correlation scale, 0.88 will fall on the range 0.81 to 0.99. And the interpretation for this one is very high correlation. Since this is positive, we can say that we have positive very high correlation or very high positive correlation. So therefore, since we have very high positive correlation, we can now start computing for linear regression or solving for linear regression, and we can now find the equation of the best fit line. So we have y equals ax plus b. Again, to find a, we're going to um, use the formula a equals n summation of xy minus the quantity summation of x times summation of y all over n summation of x squared minus the quantity summation of x squared. So let's now use the substitution process. So instead of writing n, we're going to write 7. Instead of writing summation of y, we're going to write 2,477.9. Bring down minus. Then next, instead of writing summation of x, we're going to have 556. Instead of writing summation of y, we're going to have 31.15. Now, all over, instead of writing n, we're going to write 7. Instead of writing summation of x squared, we're going to have 44,230. Bring down minus. And then, instead of writing summation of x, we're going to have 556 squared. Now, pressing on your scientific calculator, 7, parenthesis 2477.9, minus, parenthesis 556 times 31.15 close parenthesis, we can have 25.9. And then simplifying the values on the denominator, we can have 474. Dividing this one, 25.9 by 474, we have 0.05464. So as you can see, hindi ko siya ni-round up so that we can get the exact values. Maybe hanggang 4 or 5 decimal places. Okay? Next is, to find b, we're going to apply the formula b is equal to summation of y, should be a, minus a summation of x all over n. So summation of y is equal to 31.15 minus your a. So your a is this one, 0.05464 times your summation of x, which is 556 all over n, and your n is 7. So simplifying the numerator, we can have 0.77016 divided by 7, we can have 0.11. So we already have the value of a and the value of b. So substituting the value of a and value of b on y equals ax plus b, we can now have the equation of the best fit line, which is equal to y equals 0.05464x plus 0.11. Now, we will be using this in predicting the teacher's performance rating given the let result. So let's now predict the teacher's performance rating given the scores in let of the teachers. So what if the let rating of the teacher is 81? What do you think will be the teacher's performance rating? So we're going to use the formula y equals 0.05464x plus 0.11. Now substituting, so our x here is 81. So substituting the value of x, which is 81, we can have 0.05464 times 81 plus 0.11. And the answer is 4.54. So therefore, the performance rating of the teacher, if the teacher has what we call 81 as the let result, the teacher's performance rating will be 4.54, or possibly it can be 4.54. And then let's have, what if the let result is 87? What do you think will be teacher's performance rating? So we're going to have y equals 0.5464x plus 0.11. Substituting x, which is equal to 87, we have this one. 0.05464 times 87 plus 0.11. And then simplifying that, we have 4.86. So we can say that if the let result is 87, the teacher's performance rating can possibly be 4.86. 86. So that's all for today's discussion. I hope that you've learned a lot for today's discussion, and I'm looking forward that you will be watching our video tutorial even next school year. So thank you very much for subscribing on our channel. Thank you also for watching our video tutorial, and I hope that this video tutorial help you in complying your assignments, in accomplishing your outputs on your school. So don't again, please subscribe on our YouTube channel so that you will be updated with our video tutorial, and please hit the notification bell button and the like button. Thank you very much, and God bless everyone.